Hey everyone, and welcome to WittCode, where in this video, we're going to learn about the queue data structure. We're also going to code a queue from scratch using JavaScript. So what is a queue? So a queue is a data structure that follows the first in, first out principle. This means that elements can only be added to the back of the queue, and elements can only be removed from the front of the queue. For example, in this image here, every time an element joins, or enqueues, it joins at the back, whereas anytime we remove an element, or it dequeues, it leaves from the front. Queues should be used when you want to get things out in the order you put them in. A classic example is printer software. When printing a document, the document that enters the printer's queue first is the one that gets printed first. It's the first in, so it's the first out. So now let's start coding our queue. And to begin, we're going to create a queue element. And what this basically will represent is just an element in our queue. So class queue element, which will represent one of these green rectangles. And we can see what it consists of is a value, so just any kind of value it represents, and then behind. So you can see how each of these, for example, this one here, say the element is, or the value of this is like 1, or even a string like cheese, and then behind it is this one here. Say this one has a value of pizza, and then it has this element behind it there. So this is a reference to what's behind it, and this is just the value that it's holding. Now let's create our queue class. And what we're going to do is just create a constructor first. So initially our queue will be empty, which is why we have the front and back properties set to null and the size set to 0. And of course the front represents the front of the queue and the back represents the back of the queue. And now let's work on adding an element to our queue. And we're going to do this with a method called enqueue. So enqueue. And remember, elements can only be added to the back of the queue. So the way this works is first we create a new queue element with the value provided. If there isn't an element in the front of the queue, then this means that the queue is empty. So we set both the front and the back of the queue to this new element. So now the queue would be one element, where of course the first element is in the front and it's also the back. However, if the queue is not empty, then we create a reference to the previous back, and this is because the current back, this one right here, will no longer be the current back. Instead, behind the current back will be the new back. So this makes more sense by, say we call this previous back, we set the behind of the previous back to be the new queue element. So say this element here is previous back, this reference here, behind it is now this, which is the new queue element. And then we set the back of the queue equal to the new queue element. Finally, all we have to do is just increment the size by 1 and then return the size, which of course is optional, but we return the new size. And now because an element is always added to the back of the queue, the size of the queue has no impact on the time complexity for adding an element. Therefore, time complexity for the addition of an element is big O of 1, or constant time. Now let's work on removing an element from a queue, and we're going to do this with the method called dequeue. So just like this. And remember, elements can only be removed from the front of the queue. So first, once again, we check if the queue is empty, and if it is, we just return null. Next, we create a reference to the old front, because remember, we're removing an element now. So basically we need to change what the front of the queue is. So we say the previous front is what we have right now. If the front is equal to the back, which basically means that the queue is one element in length, then both the front and the back will be null. If they aren't, then we set the front to what was behind the front element. So basically we set the front here to whatever was behind it. So the next element in the queue. Then we just decrease the size and return the previous front value. And now because an element is always taken from the front of the queue, the size of the queue has no impact on the time complexity for removing an element. Therefore, the time complexity for the removal of an element is big O of 1, or constant time. But so that's all we need to do to create a queue. Now let's just see it in action. So I'm just gonna paste in some more code here. And let's actually change this to what we're going to log as a stringfied version of the queue. So we add 1, 2, 3, 4. Let's see what this looks like actually if we just run it. So when we run this code, first we place in element 1, then element 2, 3, 4, and 5. So this means 1 will be at the very front, 2 will be behind it, 3 will be behind that, and so on. Then we dequeue. Because 1 is in the front, it'll be removed. Then we perform another dequeue, and now 2 is in the front. So what's left is 3, 4, and 5, which we can see right here. So the front is the value of 3, and behind that is the value of 4. Behind that is the value of 5. And of course the back whatever is behind the back is always going to be null. But that's all there is to coding a queue. If you have any questions, leave them in the comments for me and I'll try and get back to you. Besides that, I want to thank you for liking and subscribing. If you wish to support me, please consider downloading my Chrome extension called WittCode, link in the description. Besides that though, have a good one.